I welcome all my dear students again. We will complete the last topic which is remaining in this chapter, refraction of light, which is called as dispersion of light. Now, what do you mean by dispersion of light? Simple. Just you can take a scale, hold the scale in front of any light source and just move the scales to and fro. You can see the band of colors which is formed, and this band of colors which is formed due to a light when it undergoes refraction, that is from one medium to another medium. Scale is another medium. So as light rays enter from one medium to another medium, plus there is something little more to add on that. This phenomenon of splitting of light into its component colors is called as dispersion of light. Let us first start with the definition. What is dispersion of light? The process of separation of light into its component colors when it passes through a medium is called as dispersion of light. Okay, so let us write down the definition. The process, you have to remember the word process, of separation of light into its component colors, while passing through a medium is called dispersion of light. So this phenomenon wherein light gets separated, or you can use the term split. I am going as per the textbook definition. The process of separation of light into its component colors, plural, while passing through a medium is called dispersion of light. If you hold a CD in front of the light, there also you can see dispersion of light, the colors, the band of colors, and this band of colors is called as spectra. Okay. Now, the colors that we see, normally for our simplicity, we consider only 7 colors. But actually speaking, this white light or the light from sunlight is made up of millions of colors. Okay. Just for our simplicity, we are considering only 7 colors. And we know which are the 7 colors. Yeah, you know, it is, to make it easy, we call it as Webgyor. Okay. So each and every color you are very much thorough with. Each and every color you are very much thorough with it. Violet, indigo, blue, green, yellow, orange and red. These are the 7 colors which we have considered for our simplicity. Always remember that there are millions of colors onto which the light is getting split. Now, after learning the definition, let us learn why does this dispersion happens. Okay, why does this dispersion of light happens? Why does this white light get separated into its component colors? Now, this chapter, light has a very close relation to sound. In your 9th standard, you have learnt the notes of sound. Sa, re, ga, ma. No, the different notes have different frequency. When I use the word frequency, you should remember a wave. Okay. So we can't learn frequency without considering a wave. So let me consider a wave. Now from this point, so I am considering a wave this way. Now this point we call it as crest. Okay. The crest, and the which is little sinking part we call it as stroke. The distance between two consecutive crests, that is from first crest to second crest, this distance is called as wavelength, or we denote it as lambda. The distance between any two trough, same way we call it as lambda. Okay, so we can compare light with sound. Like every note of sound has different frequency, same way light is made up of electromagnetic waves. So waves means there will be a crest part and a trough part. The distance between any two consecutive crests is called as wavelength or lambda. Lambda means wavelength. the number of waves passing per second is called as frequency. So the next important word is frequency. First important thing that you have to consider is wavelength and the second is frequency. If more number of waves are passing in given time, then that means frequency is more. Okay, now let me consider wavelength, that is lambda. This one wave, and I'll consider this wave. Okay, now as you can see here, the distance between two crest, this lambda, and the distance between this crest and this crest. Okay, this lambda. Here the wavelength is more, here the wavelength is less. Here the wavelength is more and here the wavelength is less. I am considering a wave. Let me consider a wave. Two types of wave. As you can see, this is first type of wave and this is the second type of wave that I have considered. Okay. Now, the distance between any two consecutive crests is called as lambda, or the distance between any two consecutive trough is called as lambda. Crest means the upper part and the trough means the lower part. So, any two distance between any two trough or distance between any two crest is called as lambda or wavelength. Number of waves passing at a given time is called as frequency. Okay, so here lambda and frequency are the two terms that you have to remember, wavelength and frequency. As the wavelength increases, here you can see the wavelength is more. If you consider the wavelength of this wave, here the wavelength is less. Here the wavelength is more and here the wavelength is less. There is inverse variation between wavelength and frequency. More the wavelength, less will be the frequency. As you can see, more is the wavelength, less will be the number of waves that passes through at a given time. More the wavelength, less will be the frequency. More the wavelength, less will be the frequency. Less the wavelength, more will be the frequency. Okay. So this one thing you have to remember for sound as well as for light. Light is electromagnetic waves. As you know, there are different types of radiation. No? Ultraviolet rays, gamma rays, alpha rays, infrared red rays. All these are the radiations that some radiations are visible whereas some are not visible. Infrared and all are non-visible radiations. X-rays also, gamma rays also. So, if I consider these radiations, all these radiations can be studied through waves. These are nothing but electromagnetic waves. So, waves means it will be like this. Now, in this room, there are various waves passing through me, which I can't see. Okay. The waves that I can see is a red colored bottle here, a wardrobe which is kept here. Those are the light which is reflected back and I can see. So, those are the visible radiations. Some are invisible radiations. The radiations coming out of your mobile phone. Okay, the radiations coming out of the dish which is kept outside your balcony. Those radiations I can't see. Okay, so some radiations are visible, some are not visible. Here I am talking about visible radiation. So if I consider radiation, it consists of waves. Waves consist of wavelength. Wavelength is the distance between two consecutive trough or crest. Now, more the wavelength, less will be the frequency. Like, no, those who are very thin, they can run fast. Okay. So, we can consider those who are very thin, they can run fast. So, frequency is more. Those are little stout, they take time. So, more wavelength, less frequency. Less wavelength, more frequency. Will you keep this in mind? Now, our eyes are able to see radiations of the wavelength in the range between 400 nanometer to 700 nanometer. Okay. Our eyes are able to catch the radiations of this range. These are the visible light radiation range. So, the lights which we can see, the colors that we can see are from violet to red for for our simplicity, we have called the colors from violet to red. 7 colors only we are considering. But there are millions of colors, but for our simplicity, we are considering only 7 colors. Okay, there are more colors, but we are considering only 7 colors. Now, those 7 colors are coming under this range of frequency from 400 to 700 nanometer. Now, how is this light getting dispersed? When it passes from one medium to another medium. Just by standing here, can I see those 7 colors? No. Now, you should have an additional medium there. At least you have to consider a scale or a CD, or at least there should be rainy season. Only then you can see a rainbow outside there. So, there should be a medium here which will give us dispersion of light. Now, let us see the dispersion of light happening when the light travels from a rarer medium to a denser medium, glass. That is, here I am considering a prism. The ray of light, when it is present in the air, the speed of light in air is 3 into 10 raised to 8 meter per second. This white light, when it is present in the air, the speed is 3 into 10 raised to 8 meter per second. As soon as it enters another medium, what will happen is the different colors which are present in this white light will travel with different speed. Okay. Out of that, red color has the maximum speed and violet has the minimum speed. Okay. So, red color deviates the least and violet color deviates the most. So, let us consider a ray of light in this medium. In air, the speed of light is 3 into 10 raised to 8 meter per second. As this white light enters the prism, the different colors will travel with different speed. Actually, it should go this way. Actually, the path should be straight. But what will happen? It will bend towards the normal. And each color will bend at different angle because each color has different speed in prism. In this medium, the speed changes. So, each color will bend with a separate angle. 1, 2, 3, 4, 5, 6 and 7 you have to show. Starting from here, you have to show so many splitting. Okay, this point you keep it constant. When you draw with pencil, you will be able to get it clearly. So, inside the medium, dispersion took place. Why does dispersion take place? Because the speed of different light in the medium is different. Speed of red is the maximum and violet is the least. Okay. So, here you have to show with your colors. Red at the top. Now, again from glass as it comes to the air, again it will undergo a bend. That also you have to show. Okay. And same colors. Vigor. Okay. So, here refraction again is happening 2 times. When white light enters from air to prism, first refraction. Again from the prism to air, second refraction. And this happens because the speed of different lights, different colors of light in the medium is different. Understood? Okay. So, this violet will have different speed, red will have different speed. So, they bend at different angles. Now, so if the light which is coming out, if this light is made to pass through another prism in this direction, if I keep the prism inverted, the same light which enters the prism, it will undergo refraction, and what will happen is the light which is coming out will be of single ray of light. It will be white light. If I keep another prism onto the way of this dispersed light, an inverted prism, the ray of light that comes out will be white colored light. Here the angle of deviation will be 0. Now, who gave us this dispersion of light? Sir Isaac Newton. So, this also you have to remember. Now, one more thing that you have to remember is a correlation. It can be asked this way. Glass prism, dispersion of light, and glass slab is refraction of light. In glass slab, you don't see dispersion of light. Glass slab is refraction of light and prism is dispersion of light. Where can you see this dispersion of light clearly? It is the formation of rainbow. Okay, again to see rainbow, the sun should be behind you and you should be looking at the rain. Okay, only then you can see the rainbow. Now, how is the rainbow formed? Formation of rainbow. Now, for rainbow, let us consider a drop of water. This as a drop of water. Raindrop. Let us consider a raindrop. And we have the sun here. Okay. So, this is the ray coming from the sun. So, the ray which is coming from the sun, will undergo, again raindrop will act like prism. Like we saw in prism, no? So, this raindrop will act like prism. And inside the prism, what will happen? The light get dispersed. Okay. The light should travel this way, but it will get dispersed into 7 colors. Okay. Dispersed into component colors. So, that I'll have shown. So, here the first phenomenon that happens, as the sunlight enters the raindrop, the raindrops behave like a prism. So, as the raindrop behaves like prism, what is the function of a prism? Prism will disperse the white light. So, here first phenomenon happening is dispersion of light. Now, at a particular angle of incidence, now suppose this is the angle of incidence here. At a particular angle of incidence, when the angle of incidence become more than the critical angle, at a particular angle of incidence, when it becomes more than critical angle, instead of these rays of light which got dispersed into different colors, instead of these different colors going outside, now in prism it happened, in prism what did you see? In prism what did you see? White light entering, getting dispersed, okay, and again getting refracted. Again refraction took place. But here dispersion happened, but refraction is not happening. Why? Because that angle was greater than the critical angle. When the angle of incidence is greater than critical angle, what will happen? Total internal reflection. That is the reason why I taught you total internal reflection before. Okay. When total internal reflection takes place, what will happen? All the light will get reflected back. All those 7 colors, those light get reflected back. Now at this point, here now the angle of incidence is not greater than critical angle. Okay. Second time here, the angle of incidence is less than critical angle. Now here what will happen? Again refraction takes place. Okay. Understanding what is happening here? Here dispersion took place. Dispersion takes place when sunlight enters raindrop, and raindrop behaves like prism. When raindrop behave like prism, the white light get dispersed into 7 colors. Now this angle of incidence, at a particular angle of incidence, when it is more than the critical angle, instead of refraction taking place, what will happen? Total internal reflection. So instead of the rays going out, it will not go out, it will be reflected back. All the 7 colors will be reflected back. Now at the second time, here at the second time, the angle of incidence is less than the critical angle. Here angle of incidence is less than the critical angle. So what will happen? All these rays are refracted outside. So you see the rainbow of 7 colors. Understanding? Okay, once again I repeat. As the sunlight enters a raindrop, how will you write it in the answer for your exam? As the sunlight enters a raindrop, the raindrop behave like prism. So you have to underline the word prism. Now inside the prism what will happen? First you have to mention about dispersion of light. The white light get dispersed into 7 colors. Now when the angle becomes, at a particular angle of incidence, it becomes more than the critical angle. So when it is more than critical angle, after dispersion what is happening? Total internal reflection, TIR. TIR means total internal reflection happened, because the angle of incidence was greater than critical angle. It is not mentioned in your textbook, but you should know. No, you know when will total internal reflection take place? When the angle of incidence is more than critical angle. तो जब angle of incidence critical angle से ज़्यादा हुआ, that time total internal reflection took place inside the prism. Inside the prism, that took place. Now in the second case, when the rays were reflected back, at that time the angle of incidence is less than critical angle. Less than critical angle हुआ तो now refraction took place. Now the rays were allowed to come out of the raindrop. So what you see? You will see the different colors of light which is coming out of the raindrop, and that is how rainbow is formed. Okay, so I hope you understood what the formation of rainbow. First, as the sunlight enters the prism, it will undergo refraction. After refraction, it will undergo dispersion. After dispersion, it will undergo total internal reflection. And again, refraction, and those refracted rays you see as rainbow colors. I hope you have understood the formation of rainbow as well as dispersion of light. So learn this chapter thoroughly. Don't skip any part. In the next class, we will start with a new chapter. Till then, take care and bye, students.